Ladies and gentlemen, thank you for your patience. We are ready to roll. Just as the title of the slide says, we are going to finish very strong today with one of our NY-GEO board members, and I'm not sure whether this is a clone of him or the real Zach Fink of ZBF Geothermal, because Zach is everywhere. He is probably the hardest working board member outside of John and Jens, but they're all up there, and I know that Zach has been a critical part of pulling all this together with the tours, with the session outlines, with just about everything. So I want to just introduce him and let you know that if you're interested in geothermal system commissioning, you're in the right place. For those of you that have not been in a PDH credit session, at the end of this, go back to the table in the rear of the room and see me, because I need to get a signature either on a prepared list or one that's not prepared. We'll figure that out then. As I said, Zach's been formidable, and we've been very fortunate to have him on our NY-GEO board. He's single-handedly probably been representative of the Long Island and the downstate areas, which is great, and that's why we've got the conference here. What some people don't know about him, and if he's got time he can tell you, is that he's a third generation of helping energy transitions. With that, will you help me welcome with a warm applause Zach Fink.
Hey everyone, thanks. I'll start up here and then I'll probably walk around a little bit just because otherwise I might fall asleep at 4 o'clock. And I'm also the thing that's preventing you from the bar, so I understand that. Always a great session. You think I would fix that being in charge of the schedule, but so be it. So anyway, I'm Zach Fink, ZBF Geothermal. We do everything from small single-family houses to some of the largest projects in New York City. And through that, we've gotten some good experience, commissioning geothermal systems. If you ask some people, commissioning a system might just be turning on the switch, turning on the thermostat at 4:30, saying, hey, it's blowing hot and cold air, and waiting for the customer to call and say, hey, it doesn't work quite right. But to actually start up and commissioning a system, there's a bunch of things to check. So, one of the big things is making sure throughout that there's inspection and that we're checking that things were installed correctly. A lot of what we do with geothermal is buried under the ground. So if we don't catch it as it goes in, you won't necessarily know there's an issue for a year, 3, 5, 10 years later. We spend a lot of time talking about the contractor did this and didn't tell anyone and now wants us to sign off on it and we don't have x-ray vision. So how do we verify what was put in the ground and those type of things. So we're going to talk a little bit about the bore field. We're going to talk a little bit about pump operation, circulator pumps, a little bit about the heat pumps, a little bit about domestic hot water, a little bit about BMS controls, and a little bit about just making sure the building operator knows what's going on in the building. We unfortunately see a lot of geothermal systems that the development team's gung-ho, they install it. We train the first super. About a year later, that super quits. They get a new super. The new super quits, you had a new super, and now it's 5 years later, 5 supers, and the super is buying refrigeration gauges on Amazon. And true story, by the way, and watching YouTube videos and sending me texts saying, this unit definitely needs a compressor. And you go, why? And they go, well, my YouTube video told me it's most likely the compressor. And I wanted to know, is the YouTube channel called 1-800-compressor sales? It's almost never the compressor. So, making sure that the systems have long-term operation is really vital to, success, and making sure that there's the ability to have handoff is really good. So why commission a system? We make sure that the system is working, as it was designed. We help ensure that the energy savings that the client wanted, they're actually going to realize. And part of that is making sure pumping energy is correct so the system will stay within the parameters of design. So it's not necessarily just energy, it's also long-term health of the system. Helps ensures that the correct materials or construction were utilized. whether it's the pipe, whether it was the heat pumps, whether the contractor got a good sale on closeout heat pumps. You want to make sure it was actually installed. And then the training helps ensure the long-term operational health of the system. So what's a commission? We don't just want to look at the bore field. It's very easy to say that, especially in New York City, you see this delineation that you have one contractor that designs the geothermal bore field up to a manifold or a heat exchanger, and then the mechanical engineer does everything past that. And oftentimes, the two sides are not necessarily talking to each other. So there's a change on the ground side that doesn't necessarily get reflected on the building side, or the building side heat pumps change and doesn't get reflected on the ground side, or the windows change on the project, which affects the thermal balance and potentially affects the number of boreholes. And you find out about it as you're in the building for the big ribbon cutting party, and you go, you bought some better windows, and you go, oh, isn't this amazing? And you go, we have different definitions of the word amazing. So these are all true stories, by the way. I'm not going to mention project names because some people in the audience might cringe. But so we really want to consider the system as a whole. And part of that is you need the heat pump to be working correctly for the bore field to work correctly. And if your bore field doesn't work correctly, your heat pumps aren't going to work correctly, and then you're going to get occupant complaints. Your pumps need the correct flow rates. They need to modulate correctly. You don't want to overheat the bore field. And then balancing devices. We're seeing sewer heat recovery systems. We're seeing boilers. We're seeing dry coolers. We're seeing cooling towers. We're seeing air-cooled chillers, heat pump chillers, all these different types of systems that exist to be able to balance the system. But when does that run? There's a few approaches of, we could turn it on anytime it's below 40 degrees outside, or we could put a BTU meter in, but all of those options means, are you actually dumping enough heat from the bore field if it's cooling dominant? And if you need to dump more, is there a provision? Or if you're dumping too much, there's an energy impact. So how can you prevent it from becoming heating dominant? All right, so commissioning starts early. Very early in the project, typically the commissioning agent will prepare a commissioning plan, talking about all the different items that they're going to commission, test, and go for it. Most commissioning agents start their review in the design phase. So they'll look at the drawings and talk about, does it meet the ownership requirements, and is it a system that's actually commissionable in the way that it's designed? And then, we're seeing more and more often that the company that does the commissioning is also doing passive house certification, energy certification, LEED, I can't keep track of all the certifications that are out there. It seems like there's a new one every day. But, and that's good because at least someone has eyes on the total energy usage of the project. So they're not just looking at the geothermal bore field, they're also looking at what's going on with those windows that changed and the fact that someone wants to now get rid of studio apartments and put one bedrooms in, the changes that happen, post 100% CDs that, the geothermal bore field designer might not be involved in the day-to-day. At least there's someone that's involved day-to-day. So a clear understanding of responsibilities. So most commissioning agents will start reviewing the submittals during the construction process. They'll look at a BMS submittal and make sure that, all the metering, sensoring, controls are in place. They'll talk about, do the controls meet the design intent? You would think the engineers pick that up, but not always. They're going to prepare a list, and I have an example on the right from one of the projects of kind of all the systems that they're going to commission and kind of the manner in which they're going to commission them. And that way everyone can look at it and say, hey, we have a dry cooler on this project that also needs to be commissioned. Like, make sure you pay attention to this. Or this is an item that typically doesn't exist on a project, sewer heat recovery. Let's start talking through how we're going to commission that. What does that look like long term? And then the other thing that we see is when you actually do commission, you need the contractors on site. And sometimes it's the contractor, sometimes it's the manufacturer reps. But you need the mechanical contractors, drillers there to be able to turn their pieces of equipment on and to kind of prove functionality. So when a project is purchased, make sure that it's purchased with that commissioning in mind. I see there's a question. So the question is the commissioning agent the GC or is it a third party? It depends where you are. In New York City, there's a requirement that the commissioning agent is a third party. I'm going to screw up the number. I think it's anything above 540,000 kBTUs, something like that. Yeah, something in that range requires it to be commissioned. And basically the commissioning agent needs to give a report to the engineer to sign off to get the final CO. In municipalities that don't have that requirement, we still like it to be an independent. I have a slide on this coming up, but what you'll see on you'll see on projects is, I'm making domestic hot water, not the fact that you're making domestic hot water and all of the heat pump modules come on at the same time, and that shocks your bore field, and your lead lag rotation and your staging is incorrect. So if you're testing just functionality testing and not necessarily how systems are working, there's that. So most of the time, commissioning agents is a contract that's hired by the owners direct, and that way the duty of care goes to the owners instead of the duty of care going to a contractor on the project, who might end up wanting to overrule it because they don't want to have to rework something, and budget and financial terms kind of come into play at that point. And if people have questions as we go, feel free to ask them. I'm relatively informal and can take them as we go, and if we're going to get to it, I'll go from there. Hold on 1 second. I'll have JR bring you the microphone.
Yes, one of your objective was heat pump operation, key things to check. What are those key things are in a pump operation? Obviously, pump rotates in the right direction. Obviously, you pump the pump, you check the vibration, you check how much the input and output is. What are key things to check? That's what I'm
Give
looking
me
for.
like 5 slides, and I will answer that. I have a slide on heat pumps, so just give me a few minutes and I will get to that. So bore field commissioning. So when the bore field actually goes to get started up, so bore fields in horizontal laterals or you're at the manifold. Now you need to get all the, the dust, dirt, air, construction debris, rags, Gatorade bottles, whatever happened to make it into your bore field during construction out. So we recommend flushing at least 4 feet per second velocity. I have some interesting slides that's about to make someone cringe in the audience, but that's okay. I'm really good at this, by the way. We'll get all that trapped air and debris out. One of the other things that we recommend is checking pressure differentials of each circuit. So even if you have clean filter bags, we had a project recently that we had to cut bigger flush ports in and bring a bigger pump in, that the contractor insisted that there was nothing clogged in it. I unfortunately did not put a picture of this filter bag on the slide, but I've never seen so much gravel in a filter bag afterwards. Something must have happened during construction, loop got run over by an excavator, and got full of gravel. And we caught it because the pressure drop should have been probably 17, 18 PSI through the circuit, and we were running about 50. So even though they were telling me their flow meter was reading 180 GPM, and that it was guaranteed to be clean, we made a bet with them that we would pay the cost of all the remediation. If they got nothing out, they owned it otherwise. I should have told them that they owed me twice otherwise. It was a pretty sure bet. But anyway, so you're gonna wanna check the filter bags if they're clean of debris. You typically need at least 20 passes in each direction to get anything suspended out. Check the filter bags if they're still dirty, repeat the process. There's some engineers that spec filling a water bottle and making sure there's no sediment at the bottom just to make sure there's anything suspended, micro, small in the system. And then when you're done, water side balancing, just to make sure the pressure drop of each circuits are roughly within the 5-10% of each other, and that your loops are gonna get even flow. One of the things is establish the forms relatively early on that are going to be utilized in the process. There's always a scramble about, we're about to test the first loop, the second loop, the third loop, and there's no standard way to record it, which becomes a problem at the end, where you say, did it actually happen? So this is from one Java, where we tested as we went. When you build a building on top of a bore field, we wanna make sure that before they pour that concrete, that there's no issues. So typically, flushing and flow testing would happen towards the end of the project. This one happened a little bit, ongoing. Every circuit, was progressively tested. And you'll see that, it lists a test. It also lists a pressure test and a flow test. And then everyone from the contractor to the borefield contractor, to the general contractor, to the special inspection agency, to the commission agency, sign off on it. For those of you that are not aware, in New York City, there's a special inspection agency as well, just to make life a little bit more difficult. And they're out there, in place of the engineer of record to verify certain tests. They're licensed by Department of Building to be able to do so, and they're going to make sure that pressure test was performed to the ASTM standard, and that it complies with specifications, and they're going to write a report to the engineer of record. So at the end of one job, I'm going to get a report from them, and I'm going to say, great, I wish I knew about this a year ago. But no. In real time, we're in contact with them. We're out there dealing with them. And this way, we have a good record around, what happened for the pressure test and the flow test for everything. And this was actually a standard form that the GC has. So this is like a standard Lend-Lease construction form that existed. And then you'll see after we flushed the one circuit, there's a filter bag on the right that was cleaned. And it's not our final flush. This was an interim flush. But at least we have a documentation of what had happened. And if something happened later, we had a record to go back and say, all right, sometime between April 4th and October 31st, when we actually put manifolds in and go to flush the system, something happened. What happened? And then you can go back through construction photos and figure out why there's a big rock in your system, for example. Grout testing. Grout is one of those things that I personally think gets overlooked a lot on projects. It's very easy to mix too low of a grout. I recently had a project that the owner wanted 2 grout samples per borehole. And somehow we couldn't count, so we did 3 and 4 on some. So we did about 1,000 grout samples over the project on 300 plus boreholes. And I was kind of shocked that it was the same crew. So, they were running one grouting crew for 4 or 5 drill rigs, and we had a 30% difference in the same crew mixing grout. So I bought a portable grout tester that ended up working pretty well because getting samples back 2 weeks later didn't necessarily mean a whole lot. But making sure that the grout meets the specifications, too high tends not to be as much of an issue, with the exception of a cement-based grout where you have chlorides concerns that might transmit down the borehole. But making sure that that grout sample is at least meeting the thermal performance of the project, and that it meets the engineer's specifications, so it doesn't act as an insulator and it's going to promote heat transfer to the ground around it. Most grout manufacturers have free sampling. They'll ship you a sample container, you fill it up, you ship it back to them. They send you a report a week later. They wash the container, they'll send it back to you if you want to do more samples. And then the other thing is define parameters beforehand. So you get a low grout sample. Do you reject that borehole? Do you keep it? Is that borehole worth 3/5 of a borehole? So don't test just to test. We see a lot of specifications out there that say, test every 10 batches of grout. But what is the acceptable range? Is it plus minus 5%? Is it plus minus 10%? Is it just a minus and not a plus? If someone specifies a 1.2 grout and someone gives you a 1.8 grout, are you necessarily going to reject it? And at least outline the process, up front. Same thing with loop lengths. You drill a 500-foot loop. Not every loop goes in every depth, and it's not always practical to pull out that loop to kind of reset it and re-go. So if it's 499 feet instead of 500, we'll probably accept it. Do you accept it at 480, 470, 460, 450? Where's that judgment cutoff of where you can't accept it? And from a contractor, it's very tough to know where those parameters are. And then when you go to commission the system, you ultimately need to know what was built to know what your pressure drop should be to make sure that you're getting your correct flow and you're balancing. So someone ultimately needs to keep a record of all those changes that got approved or just just happened. Flushing and filling the system, this is one of my favorite photos. The contractor on this job showed up with a little transfer pump, might have been enough to empty a swimming pool in about 3 weeks, maybe 4. And that is what they flushed their commercial geothermal systems with. This was a contractor that had done geothermal before for commercial buildings. I don't know how they've ever commissioned a building and how they worked. Sometimes things work by accident, I guess. And the people were moving in on Monday, and it is now Tuesday of the previous week. So not many options to get the actual flusher equipment out there. We call United Rentals. We get a big pump out there to give us our 4 feet per second velocity. This might have been the oldest pump I've ever seen in my life, by the way, like literally leaking oil on the brand new concrete. And we needed a tub to act as our, sediment tank and, filter our water. Turns out dumpsters are readily available. 10 mil plastic is accessible at Home Depot. And about 4 hours later, we had a flush system. We did have a big filter setup, way bigger than needed for the project, but when you're waiting on the local United Rental and they go, we got a big one we could pick up from a site down the street, you say, okay. So we could filter significantly more, and then that's a picture of the filter bag kind of as we changed it. That's not bad. That was a few flushes in. But making sure you have the correct filtration equipment, making sure the submittal's approved early on to make sure that there's no kind of surprises later is always good. Even just back checking the pump curve. It's easy to get into a compliant method of saying, I flush buildings all the time, 100 apartment buildings, 50 loops, that's kind of our bread and butter. We use this pump. But, from engineer to engineer, some engineers might have 3-inch or 4-inch for laterals, some might have 6. So there's going to be some difference in pressure drops and flow rates that need to get flushed at. So just a quick plot of the curve to make sure that there's no issues and that the equipment going to be on site meet specifications is huge. What you'll typically see is, I joke around about it, you get about 5 people all standing around watching one person work, and the owner's paying each of those people hourly. So that quick check can save the owner literally thousands of dollars a day. And then once you've cleaned the system, you flush it, you're ready to go, you need to put the glycol in. So with glycol commissioning, we see a few things. One is making sure that the water quality that's in the system aligns with the manufacturer specifications and the project specifications. So how are you going to disinfect the water? Do you need to disinfect the water? Every manufacturer has slightly different, requirements and guidelines for that. Do you need deionized water? Do you need premixed water? After you put the glycol in, do you need to add additional inhibitors? All of these things. How is the glycol going to be tested? Most glycol goes in, as a virgin 100% or 95% mixture, and then it circulates for a few days or a week, and then you take another test. But have we thought through the process of if the calculation was wrong and we don't have enough glycol in the system, how do we add more glycol? What does that look like? Do we have enough on site? What does the supply chain look like for the glycol that's there? We used a product called Killfrost on some of our projects earlier, which was a glycol manufactured in Europe, which was great. It was lower viscosity. But now we're having trouble that they've kind of ghosted the US market. They're in the process of coming back, allegedly. And, we literally have some on a ship right now waiting to get to us, and we thought we were going to have it, and then the ports went on strike. So we had to push back the leak repair on a project because we couldn't get enough glycol to be able to fix the leak. So, glycol selection, what does the supply chain look like? What are your options and outs are all important. And then most glycol manufacturers offer free annual testing of the glycol. So they send you a little sample bottle. They really dislike when you ship it to them in a Poland Spring bottle, but they will test it. I'm a contractor at heart. Get us a water sample. You tell that to one of your technicians. You end up with a Poland Spring bottle of water. Yeah. And then, so test it and make sure that the inhibitor levels and those type of things are correct. Most projects will ultimately hire a water treatment company to maintain the water treatment, and a lot of them will do circulator pumps as well. So heat pump commissioning, so what we typically see is what we call functionality testing first. So the manufacturer or the contractor goes through each of the heat pumps, and they fill up a startup form. This is a Climate Master one from their new 454B vertical stack heat pump, where they want you to record a certain amount of information, what your entering and leaving water temperature, what's your return air temperature, what are your air differentials, what's your water differentials, what's your voltage. Some jobs will take it a step further where we'll calculate out what's the COP and EER of the system to make sure there's not a refrigerant charge issue, which you can pick up at that point. And then when the commissioning agent comes through, typically it's done by random sampling. So we see somewhere between 5 and 20% of the heat pumps kind of get identified. They first make sure that they're signed off by the technicians on the project. So someone went through them, and it's not the first time someone laying eyes on it when the commissioning agent came out. Keep in mind, commissioning should be post-validation, not necessarily troubleshooting. It happens sometimes, but ideally it's, let's make sure that the item that's working is actually working correctly, not let's figure out how to turn on the heat pump. And then they'll go through and they'll check some of these things. They'll check the airflow. They might, independently put a duct hood on it just to make sure you're getting the CFM. They'll check to make sure that the unit doesn't sound like it's rattling and about to take off. One of the big things we see is, so when you do vertical stacks or large apartment buildings, they put a sign on the door and they'll say, this is, unit type 1, and that gets a chassis A, and this is unit type 2, and this gets a chassis B. And we've had a number of projects that something happens and somehow chassis B ends up, the 2-ton unit ends up in the 245 square foot studio apartment, and the 2,000 square foot penthouse somehow ended up with a half-ton unit. So making sure that the correct units were put in the correct area. And with anything, if you start finding issues, then you increase your sampling. But if you test, 10% or 15% of the apartments and they're all correct, you don't necessarily need to go through everyone. It's a lot of time random sampling based. By the way, it is a pain when the wrong units are installed in the wrong apartments and then they're sheetrocked in. Not as much if the chassis sizes are the same, but when the chassis sizes are different, your developer's worst friend that day. From experience. So other heat pump commissioning items, make sure the condensate drains are working. That's probably our number one service call we see, just condensate moisture. And when condensate drains overflow or the sensor switch was blocked out on a vertical stack job, you get the call that the water is raining from the apartment above, below type deal. And that's definitely not what you want. We've had a lot of issues with zone valves over the years that, people jump them out. One of the first projects we did, the developer refused to properly flush the system. They've never done it on any of their other systems. They didn't need filtration. And it was ductile iron pipe in the building, and it has all the flakes in it. If you ever look at the water from that building, it is pitch black, and you would not want to drink that water. So I'm going to tell a few stories about this project as we continue. But one of the things was half of the zone valves came as normally open and half of them came as normally closed. And the project engineer, we nicknamed him Houdini because he somehow had a magic trick to make everything work, went through and pulled out the flow regulator valves and the zone valves. And I walk in one day and he has a box of at least 50 zone valves on his desk and goes, "We don't need these." I take these out and the heat pumps just work great. By the way, I lost the battle to get them reinstalled, and it kills me because every time I go to this job, the pumps always are running at 312 GPM, and they do not modulate. But, making sure that your heat pumps are working correctly. The other sad thing in New York City is, you can write a commissioning report that says these are all the things that are wrong, and if the engineer accepts them, there's no actual, redress, unfortunately. You have to rely on the owner wanting to do the right thing. And actually wanted to fix the defects. And that, and they're correct. So if they're supposed to be normally open or normally closed at the correct direction, that they open and close when the heat pump calls. We've seen zone valves not wired. We've seen bad solenoids on units. We've seen, you name it, we've seen it. And that affects pumping. And then filters. I can't tell you how many times we go to a unit and it doesn't have a filter installed, has 2 filters, 3 filters, has the wrong size filter. Somehow filters are kind of the toughest thing to get right. You think the bore field would be the toughest, but filters at that point. All right, so pump commissioning. So it's really make sure that they're following the correct curve and that they're following, design intent for the project. So we see a lot of sensorless pumps, but more and more we're starting to see projects that work on temperature differential. Which requires a relatively complex control system to know if you're in heating and cooling mode, and then modulate, effectively based on the, the upper or lower bound. Lead lag, parallel pumping. You want to confirm the strainers are clean, that they're accessible. We have a job that the way the pumps were installed, you need to drop the entire pump instead of being able to open eight bolts at the back of the strainer. So it is a two-person, multi-day job to change a strainer on a pump. Someone built a wall afterwards and didn't talk to the pump guy. I'll tell you, developers always love finding bonus space that's like really mechanical space that, is now the great place for, the mailroom or, whatever. All right, we went over the glycol. Pipe insulation, that's a big thing we see. In New York City, there's an exemption in mechanical code that you don't need to insulate piping that has fluid temperature above 68 degrees. So you see a lot of boiler tower systems with uninsulated risers in the building. And that's probably the number one pushback and change from a mechanical contractor side in the city from installing a boiler tower system to a geothermal system is needing to insulate the risers. For some reason, it is next to impossible to get a geothermal manifold insulated. It's one of those things that it's required to be commissioned by code. If it's not commissioned from the temperature change in the condensation, you'll see the valves corrode and rust out over time and potentially leak. So when you get to the point of actually testing the heat pumps, it never happens on that beautiful 95-degree day when you can actually turn them all on cooling and test the peak event on the loop field. So how do you simulate a load? Well, you open the windows, you run half the heat pumps in heating, half in cooling. You turn off some of the ground loops to simulate a hotter load loop temperature, to bring your temperatures down or raise them up to make sure that your pumps will modulate correctly and that your heat pumps won't lock out. That antifreeze dip switch settings were set correctly on the heat pumps. When we did that same project, which was vertical stack heat pumps, the manufacturer rep in the city had yet to do a geothermal job, although they claimed to have done many at that point, and was arguing with me that this manufacturer had a jumper that needed to get cut on the unit for antifreeze protection. And they go, well, we've never cut that jumper, so we can't jump it. So they went through and they what they called commissioned, but really functionality test 100% of the heat pumps, to then get an email from the manufacturer to say, yes, our spec book is correct. Yes, you need to cut that jumper, to have to go back to all of them to enable the antifreeze jumper. So even though you're buying product from experienced contractors, they sell tens of thousands of heat pumps a year, you need to make sure that that they're not going to lock out and break and die and all those other bad things at peak extreme temperatures. Domestic hot water. You can simulate a domestic hot water load, which also runs the lower bore field temperatures. Run an electric heater, run a dry cooler. There's ways to get temperatures up and down in the bore field to really try to simulate it. Our goal is to try to find that problem before it's a peak day. We don't want to call in the 95-degree day to say the bore field temperature got over 120 degrees and the system failed. We really want to know about that, earlier on and make sure that bore field's resilient in exchanging the heat that it was designed. Controls. So building management systems, we see a lot of sequence issues. If anyone ever sees a SMITO review on a BMS system for me, I basically write, please have your programmer on site and I'll figure it out as we go. That is not the correct way to do it, by the way. But a lot of the controls that we're doing these days are not necessarily, off the shelf. We have a lot of custom and we have a lot of, we're starting to look at projects and whether it's our end client, if they're, an ESCO, has a performance guarantee in the system and they decide to guarantee something that I recommend against, like your water temperature will never go above this magic number. So can you use domestic hot water to shave the building peak? So you have to make sure that those things are in it. If the water temperature gets above 85 degrees, can we raise the hot water heat pump set point to avoid, a contractual obligation to pay a penalty that I don't actually know what it is? Can we test fire the BMS sequence for, whether it's fire alarm shutdown or recovery from whatever event it is, to make sure that, the sequences work and that, occupied, unoccupied modes, et cetera, are correct. Is fault monitoring enabled? I love BMS systems that send me emails, and then we go in to try to find out what they were, but no logging was set up. So you have no clue what actually happened at the time. I also really like when they set up email alerts and no one knows what to do with it. Your system is in catastrophic failure mode. Great. A, what does that mean? And B, what do you do about it? So that goes into operator training that we'll talk about. And then, consider a BTU meter on the system. We're starting to put them on jobs more and more to just look at what is the ground loop exchanging? Is there a thermal balance issue? Did something happen like the ventilation got turned on to high and is now running at 100% instead of at 50% or demand-based? So it kind of an early warning of, issues before they happen. Domestic hot water, one of my favorite problems to solve on projects. So domestic hot water we're seeing can be about 50% of the HVAC energy in new construction buildings. We're oftentimes seeing the domestic hot water load of the project being greater than the heating load. And I feel like it's the thing that gets the least amount of attention in both design and sometimes in commissioning, unfortunately. As soon as you have hot water at the faucets, everyone wants to stop talking about it. And unfortunately, that's probably the time to talk about it the most. If anyone hasn't seen it, I can share it afterwards. There's a NY-GEO study that was done about a year and a half ago where they looked at hot water use in multifamily buildings. And I was shocked with how low flow fixtures are these days. The hot water recirculation can be up to 45% of your domestic hot water load, which is insane if you think about it. You get a 100-unit apartment building, and you're using, half of that energy is from the recirculator pump going. So is your recirculator pump balanced correctly? Is it at the right speed? How much more flow are you running than need be? Is it on a timer? Is it demand-based? There's tons of different ways to control it, but that's probably one of the single easiest things a developer can fix on their project to actually be able to meaningfully save money. Hot water storage temperatures. This is a fun one that we run into a lot, that depending on the technology, some technologies you would like to store hotter because you actually have more efficiency. So CO2 heat pumps, R744 heat pumps, become more efficient with the greater lift. So it is more efficient at 140 degree lift, 40 degree entering to 180 degree storage temperature than it is at 100 degree lift, 40 to 140. Link, which is the big name currently that is selling CO2 domestic hot water heat pumps, will advertise that they can store up to 170 degrees, except had a problem for a while that they have an interim heat exchanger that looks like these guys here that really only made them capable of 140 degrees. That would added about 15% to the energy cost for domestic hot water. So they were out there rebuilding them very quickly after we pointed that out to them. Plus, you get less hot water capacity. If you have a 410A, 134A, R32, 454B, or whatever the new refrigerant of the week happens to be, they typically become less efficient with the higher lift, which means then you want to put it at whatever needed to get designed to maintain operational of the building to have enough hot water. But if that's 145 degrees for Legionnaires, you want to store at whatever that temperature is. You don't necessarily want to store at 150, 160, 170 because you're going to have a performance hit and then extract less heat from the ground plus the energy on the building side. Mixing valve temperatures. We see mixing valve balancing not always happening. So you're running sometimes hotter domestic hot water plants to, deliver the same water temperatures. Recirculation line temperatures, they're correct. We've had a project that they've been crossed recently. Flow rates are correct. And then on the heat pumps, can we simulate a load? I always love opening the valve on the last storage tank, letting it all dump out and watching how fast it recovers and making sure all the modules don't come on at exactly the same time. Because one of the biggest expenses on electricity in the buildings are demand charges. It's not the kWh. So if we can recover domestic hot water as a 16-hour cycle and have enough storage capacity, it's a smaller impact to the ground loop. Plus now we're mainly recovering off-peak. So we're not recovering between that, the peak time that the developer gets charged the most. So when we originally went to start up this project, we have the 3 modules, and the manufacturer goes, well, we set it so all 3 modules run, because you have a redundant module, but you get hot water faster. And we had to spend a lot of time explaining on a geothermal project, that's bad. We want the long run time. We have enough extra storage capacity. By our count, we had twice as much storage capacity because I love this engineering line. No one ever got fired for putting an extra storage tank in. So plenty of storage capacity on this project. And we made them come back out and change it so only 2 modules run at a time, and that there's the hour delay between the 2 modules to make sure that's in a high demand situation. And if you look at, hot water performance curves, about 25% of the hot water is used during that morning peak, and will recover before the afternoon peak with just 1 module running. So why run more, have an extra 30, 40, 50 kW of demand charges? Operator training. So typically it is a lot of people walking a building and watching someone talk, but it's important. So how much does the building operator know how to operate the system? In the event of an issue, do they know who to call, how to handle it? Have they established a service contract? Do they know who the manufacturer is? Do they know the 1-800-FIX YouTube channel of the day? Did they get their EPA certification before they bought refrigerant gauges? All these major questions of life. Does the building have extra filters on site? Or do they have a contract with a filter company? You're talking 15, 20 cases of filters for, a medium-sized building. Do they have storage for those? What does it look like getting tenant access into the apartments? And then has the operator been trained on the BMS and the control systems? Which is a big one that, you get an error code. Somehow I always get added to the email thread, and they always expect me to be the first response. That's always the worst idea. So example of fault notifications. This is from my Terrytown project. You get an alarm. You can also set it so you get an alarm notification when it's normal again. So, someone was tinkering with the system pressure got a little low, glycol feeder pump did its thing. You get an email 5 minutes later that says it's fixed. It's great. If it ever bounces to safety, you get about 400 emails and you can get nothing else done in your inbox, but that's a different story. And then also, this is a domestic hot water control picture of there's a big fault light on it. Does that fault light transmission back to the BMS system? Does the super know on a daily basis that when they do their walk to make sure that the building's not flooded, they see the big red blinking light, that it indicates there's a problem, let's do something about it? And how do you, and we don't need the supers to be, experts in everything. It's mainly we don't want them to tinker with what they don't know, which is a big one, shockingly tough to get across. And then, knowing enough that there's a little eye on that screen that gives you the error code and the readout of what it is. And when you call and say there's a problem, have that information handy. It is a lot easier because it might be, voltage fault. And they go, oh, all the lights in the building flickered last night. There was a voltage surge. The transformer outside got hit by lightning. Reset it and it'll work beautifully. You don't need a roller service truck. It could be low refrigerant charge and you go, that's bad. You need to get a technician out there and, look at it and diagnose it. So on that note, I will ask if anyone has any questions and recognize that it's almost time for happy hour. Hold on a second.
Yeah, when there is a fault notification, who would you call? Electrician, plumber, mechanic? Fink, who would you call?
I am always the worst option to call, for the record. No. So the question was for a fault notification, who do you call? For voltage, typically you start with the HVAC contractor. It's their piece of equipment, and let them determine, what it is. There's a lot of things in it, depending on the heat pump, there's a lot of things that can cause a fault notification. It could be a compressor. It could actually be a fault issue. It could be a loose wire nut, a loose, wire under the lug nut. So start with the company that installed that piece of equipment, and then they can firm it out and go from there as needed.
When you're doing the flushing, you said to flush it, I think the full volume 20 times. How are you keeping track of the total volume for each time?
So we'll calculate out that if it's 100 GPM that we're flowing at, what that ends up equaling in feet per second, because we need it back into 4 feet per second or 5 feet per second or, whatever the spec is.
Yep.
So we're looking at what is that? We know how many feet or miles of pipe we have out there, and then we know how long it passes. A lot of systems, it's somewhere between 6 and 10 minutes
So you'll time
a
it.
pass.
Okay, okay.
So ultimately, it ends up being time driven. You can also put a water calc meter on it, so you can count the gallons going through it type deal. In theory, you could put food coloring in and see when it comes back into your tank, and that's one pass type deal. But a lot of times we just do it by calculation. We know about how long it should take, and go from there.
And then, do you know off the top of your head, the NY-GEO study, the title of it that you talked about for the domestic hot water data?
No, but I can get it for
I'll
you.
get with you after.
Yeah. It's a Hugh Henderson study. Yeah. It was commissioned for the JUs for their rebate program. That's about all I remember.
For the 4 feet per second, if you have multiple size pipes, do you go with the largest pipe because you assume that it's faster through the smaller?
Good question. So the question is, how do you size that 4 feet per second? So we want that to go through all pipe segments, which likely means that you're going to have segments that end up being greater than that. It's something to be looked at during design, because there is such a thing as designing an unflushable system. That's not as much a commissioning item as a design and make sure that it can actually be built item, but yeah.
Or would you have to do it like a 2-stage flush, potentially?
It's not that. It's, say you have a 4-inch main header, and you have all your takers off of it.
Right.
It's really tough to get the air out of that last one
Right.
if you don't reduce down.
Right.
So how much, and then you end up with a limitation of how much volume can you get through, say, an 1.25 inch loop.
Right.
So if it's
Exactly.
4-inch and you're going through an 1.25 inch loop, don't ask why. I know this 4-inch pipe needs about 175 GPM to flush. That 1.25 inch loop needs about 19, which means you're going to have about 500-ish feet of head to be able to get through that loop, which means you need to go borrow a fire truck or 2 or 3 or 4. And probably exceed the pressure rating in the pipe and blow it apart in the process.
Right.
If you ever do one of them, call me. I'll come out and see it. Stand far enough away, but I'll be out there.
Thank you.
When developing a commissioning plan for your system, is there any organization that provides, I guess, example commissioning plans, or is that something that you really have to do system by system and lean on the BMS operator and the manufacturer for?
I actually don't know. All right.
I'm a commissioning agent, so I know the answer to this. So organizations like BCXA do have examples of what a commissioning plan would look like, but if you have a good commissioning agent, they are going to do it per the building. They're going to make something custom.
Sorry, maybe a bit dumb question, but you just mentioned about few fire trucks to flush the whole system, and I mean about 500 psi, probably higher pressure to be able to do so. And I just trying to understand, I mean, the working pressure of it, because all the system is HDP pipes, correct? And most of them is rated to like 200 psi operating pressure, maybe 250 at max if it is DR9. So how do you basically? Oh, I'm missing something. Maybe these pipes.
That was an example of a system that you couldn't flush. So
Okay.
I was saying that you're going to exceed the pressure rating of the pipe, and it's a design that's going to basically be unflushable.
Okay, get it.
On that
once,
note, happy
going
hour.
Twice. Okay, how about a round of applause for Zach? Thank you. For credits, please see me at this table in the back. Thank you. Enjoy your evening, and don't forget about our keynote speaker for dinner.